Hello, this is Professor Data. In this tutorial, we will look at some common ways in which you could customize or modify a dataset to prepare it for analysis using RapidMiner. So specifically, the tasks that we will be looking at are how to rename an attribute, how to select a subset of attributes, setting one of them as the dependent variable, handling missing values, and partitioning a dataset. Now, these activities are generic in that you could be doing them for any number of different types of analysis. You could be doing prediction, you could be doing classification, decision trees. For any and all of those kinds of analysis, you could be doing one or more of these activities, which generally fall in the category of data pre-processing. Now, I will discuss these activities using a used car data set from India that has about 6,000 records. And there are 12 attributes, some of which are qualitative, some are quantitative. Now, even though these activities are generic, to give context to our discussion, just assume that we are trying to build a regression model to predict the price of the used car based on a set of independent variables that are there in the data set. So let's start up RapidMiner and see how we would carry these activities out. So here we have our RapidMiner user interface. I've already imported the data set for us. So if I look in the data folder, this is the data set. Let me pull over the operator that will import the data set. And before we start looking at these tasks, at these different activities that I listed just a minute ago, let's first take a quick look at the data set to get a sense of what we're dealing with. So now if I run this process, which all it would do is retrieve the original data set. So you can see the attributes. You have the model name, the location of the car. These are different cities in India. The year of the car, the number of kilometers it was driven, the type of fuel, transmission, and so forth. And finally, you have the price, which is in lakhs of rupees in Indian currency. The actual numerical value doesn't matter for us. So it's the price of the used car in Indian currency, in rupees, okay? So this is the raw data that we have, and a quick look at some summary statistics. I just want to point out a few things. For some of the attributes, for example, for mileage, RapidMiner is summarizing for us that there are 2 missing values. There are 14 missing values for engine. There are 121 missing values for power and 20 missing values for the attribute seats. So let's keep that in mind as we go through this discussion. So you can also see that some of these, the names of some of these attributes, so you can keep those in mind as we go through the design. So the first operation that I'll show you is how to rename an attribute. There could be any number of reasons why you might want to rename an attribute from what it was in the original data set. Part of it could be that the original name is too long, or it is not quite appropriate for the kind of analysis that you're doing. You might want to put a prefix in front of it. So any number of reasons that you might want to rename an attribute. So let's see how one would go ahead and do that. And if in the operator panel, if I type in rename, you can see it gives you a number of choices over here. I'm going to pick the simplest operator, which is the rename operator. Now, before I proceed with the discussion, just a quick note. You can see these other options which says rename by replacing, rename by generic name, rename by constructions. These are more sophisticated ways of renaming attributes. So for example, when you do rename by replacing, you can replace parts of a variable name. So you can select substrings and replace them by other things. So it's a more sophisticated way of renaming. I just picked the sort of a simple-minded operator, but usually the more common one, where you take an entire attribute name and completely replace it by a different name. Okay, so here's the rename operator. If I click on it, on the right hand side in the parameter panel, which is context sensitive, RapidMiner asks you what's the old name of the attribute, what do you want to change it to. So I will pick one of them, and I happen to pick kilometers driven. I just find that attribute very long, just takes up a lot of real estate. So I will just replace it by km. Okay. And also, if I want to rename more than one attribute, I could click on this button which says edit list and change any of the other one. As it so happens, there is another attribute whose name I want to change, and that is mileage. Usually when we hear the term mileage, we tend to interpret it as the distance that the car has driven. But in this data set, mileage refers to the gas mileage, which is the fuel efficiency. So I would prefer to replace this by the name, attribute name, fuel F. But you get the idea behind how you would change the name. So once you've got your list of names that you want to change, you just apply and then run this process. If I run this process, you can see that the attribute names have changed. So you have kilometers over here, and you have, if I scroll over, instead of mileage, you have fuel efficiency. So the attribute names have been changed. All right, let's go back to design now and look at the next task, that how one would go about doing it, and that is how to select a subset of columns. The reason why one might want to select a subset of columns from the original data set is that one data set often serves multiple kinds of analyses, and you might need different subsets of the original data set for different types of analysis. So that's a common reason for wanting to extract a subset of attributes. The other reason is you might want to be building different kinds of models with specific variables in them. So let's see how one would go about selecting a subset of attributes. So once again, I go to the operator panel and I just type in select, and you can see you have the select attributes operator. I just bring this over and position it here right after the rename attribute. And then when I highlight select attributes, I go ahead into the parameter panel and I tell RapidMiner, hey, I want to select a subset of attributes. Okay. And I click this button which says select attributes. A dialog box opens up from which I choose the attributes that I want. Now remember, the specific context that I'm talking about here is building a regression model to predict price. And just for convenience, I'm going to pick some numerical attributes. The objective of this tutorial isn't to teach regression, but to show you how to do these common tasks of selecting attributes and so forth. So here is price is one of the attributes that I select. So I can pop it over to the right hand side. And the other thing that I can do is select multiple attributes at the same time. So I have seats. So I'm holding the control button down here. Power, kilometers, and fuel efficiency. These are the other numerical attributes that I have, and I pop them over. So I've got the list of attributes that I want. Okay, I apply, and now if I run this process, you can see that I have selected only those particular attributes. And furthermore, you can see that the name changes that I had made with the previous operator are in effect. So I have KM and a fuel efficiency for the two changed names for the attributes. So let's go back to design now. So you've basically seen how to select attributes, but let me show you a small nuance here. Let me go back to select attributes and to the dialog box that shows up. So let me pop these attributes back to the original list. Suppose I wanted to get these 8 or 9 attributes. Let's say everything from fuel efficiency to year. Those are the attributes that I want. Okay. Then what I could do, of course, is to select those 8 attributes and pop them over to the right. Instead, what I could do is select attribute 1, engine, and fuel type, just those 3. That is, select those 3 and then invert the selection. So get the complement of those 3. And if I run this process, you would see that RapidMiner select the remaining attributes. So it just depends how many attributes you want to pick. It's like doing 1 minus. You could select a few and then invert the model, or if you really need just a few attributes, you just select those attributes themselves. So let me go back to design and modify and reset what I just did so that I can get back the numerical attributes that I want. So I put these back, I select seats, price, power, kilometers, and fuel efficiency. I pop them over, I apply them, and I uncheck the invert selection. So I'm back to where I was originally. Just to show you that, here are the attributes that I selected, the numerical attributes with which I'm going to proceed further with the next operation that I want to show you, which is how to identify one of these variables as the dependent variable. And you do that with the operator set role. So different variables can be set to different roles. So you have this operator called set role, and I bring this over and I pop it over into the chain of operators that I'm building. And now with set role, if you go over to parameters, RapidMiner asks you which attribute roles do you want to set. So I pick up price because that's the one I want to predict, and I want to identify that as the dependent variable. And here in the target role, I identify it as a label. That's the term that RapidMiner uses for a dependent variable. That's the label. Okay, so I've identified that. Now you can change the roles of other variables as well. You can use this particular button, the edit list, and keep adding to that list. But the more common one is you identify one of the variables as the dependent. So I can run this particular process, and you can see it's the same attribute list, of course, and you can see that price here is the dependent variable. It's shaded in green. That's the label that you have identified. So let's get back to design now. By now, you have seen three specific operations that we have done. That is how to rename an attribute, how to select a subset of attributes, and how to identify one of them as the dependent. Now, next item that we will see, next activity, is how to handle missing values. So just to remind ourselves where these missing values are, let's go back to results. And if I click on the statistics button, you can see that fuel efficiency had 2 missing values, power had 121 missing values, and seats had 20 missing values. So just keep those rough numbers in mind. So how do we get rid of missing values? Now, there are a number of different ways to handle missing values. The simplest and perhaps the most common method is, if any row has a missing value, one or more missing values, just get rid of that row. Okay? So let's do that first, and then I will show you variations of how one goes about handling missing values. So if your corrective action to handling missing values is to remove the entire row, then the operation that we use is filter. Did I spell it? Okay. So you can see here this operator called filter examples. The term examples is what RapidMiner uses in lieu of rows. So it doesn't say rows, it says examples. So I want to filter rows, so I want to filter some examples. So I put my operator in this chain of operations that I'm building, and I go over to filter and then tell RapidMiner, hey, I want to add some conditions based on which the filtering should be done. So I click on add filters, and RapidMiner comes back and says, okay, what filtration condition do you want to apply? And you have a whole bunch of attributes here. You have more than one. So remember, we had 2 missing values for fuel efficiency, right? So let me pick fuel efficiency. And then the filtering condition I tell RapidMiner is filter it such that it is not missing. So only pick up the rows in which fuel efficiency is not missing. Okay, so I apply this. Okay, and now if I run the process, I don't know if you noticed, there were 5,997 rows before we applied this filtering. 2 of those rows were removed because of fuel efficiency having 2 null values. So you now have 5,995 rows. So we will add a couple more filters, and you will see this number of rows, records in the dataset reduce even further. So we have 121 null values for power, so it should reduce by another 121 at least. And then we have 20 null values for seats, so it should reduce even further. So at the very, you should see this number 5,995 reduced to 5,800 and something once we are done with removal of missing values. So let's get back to design. I click on filter, go back to add filters. So my filter for fuel efficiency is already there. I want to add some more filters. For example, power has 121 missing values, and I say power is not missing. Then I add yet another entry, and this time it will be for seats. Seats again, I will say seats is not missing. So I'm done applying all my filters. Okay, now if I run this process, you can see that the number of records has gone down from 5995 to 5872. You can do the math and you will see that the the missing values have been, the records which have missing values have been eliminated. And just as a verification, if I click on statistics, you can now see that none of these attributes, they don't have any missing values. None of these attributes have any missing values. So we have taken care of the missing values. And typically when you're doing analysis, for instance, in regression analysis, the data set should not have any missing values. Otherwise, we'll have difficulty computing the coefficients and so forth. So this is the most common method of dealing with missing values, which is to just remove the row altogether. But as I mentioned, there are some other ways of dealing with missing values. Okay. So if I just type missing, I will not actually do them, but I'll show them to you. So one is you can replace missing values. Okay. For instance, I could replace all missing values by 0. The other is you could impute missing values, where you take every missing value and you replace it by the average value for that attribute. So you could also declare a missing value as missing. You could replace infinite values. So there are a number of different options where you don't get rid of the row altogether, but you replace just the missing value by some kind of default that's either specified by you or that's computed by RapidMiner. And you can explore these options on your own. For example, if I just bring up this operator called replace missing values, if I click on the operator, then in this help panel on the right hand side, which is also context sensitive, you can just quickly read it up and see what are the different options that you have, what do each of these ports mean, and what are the different alternatives to replacing, for example, replacing with 0 or replacing with the average, things like that. All those options you can see by a quick look at the context sensitive help function on the right. Since those missing value alternatives are more complicated, and I will not discuss them right now. Perhaps when we get to analysis tutorials, I will have an opportunity to look at them in more detail. So let me delete this operator for now. So that operator is gone. So in terms of what remains to be done, I need to show you how to partition a data set. So remember, this data set had about 6,000 rows. Why might you want to partition a data set? So when you're doing data mining or you're trying to do machine learning, typically you have an algorithm that you're trying to train. And then once the training is done, you want to see how good the training has happened, how well you have trained the algorithm. So what one typically does is you take a large data set and you partition it into a training data set and an evaluation data set. So that's one common reason for splitting a data set. And then you use one portion to train and another portion to evaluate. So let me show you how one would go about doing that kind of splitting. Okay, so the operator that you use, that RapidMiner uses for dividing a data set into partitioning a data set, is called split. But even if you type in partition, RapidMiner will come back and tell you what the operator is. So there are two ways in which you can split data. One, there's a split data operator, and there is a split validation operator also. The split validation operator is a little more sophisticated. And again, for now, I will not go into that. For our purposes, this split data operator will be just fine. So let me stick it in here and let me first connect the output port of our filtration process to the input port of the split data. So everything, the raw data starting out from retrieve the raw data, rename some attributes, select a subset, identify one of them as the dependent variable, and then throw out the rows records that have missing values in them. And now we are ready to split the data set into a training data set and an evaluation data set. So if I click on this operator, you can see over here one button is used to tell RapidMiner how the split is to happen. So if I click on it, you get this dialog box, and the first thing I want to do is say, okay, the first partition should be 70% of the data. There's nothing magical about 70%, which I'm writing as 0.7. You could make it 80% or 60%, but sort of a rule of thumb, a norm, is that you use 70% of the data for training. And then I will add another entry to say that the second partition will have 30% of the data is 0.3. Okay, so that's the second partition, and we will use that for evaluation. So I've specified to RapidMiner that I want this data set split into a 70-30 split. So the second button that you see over here is what RapidMiner uses to decide how to pick the 70%, how to pick the 30%. So if you pick linear sampling, what it does is it will just take the list of records that you have, and the first 70% it will put into the first partition. The remaining 30% it will put into the second partition. Now, if you choose shuffle sampling, which is one of the default, what it does is it randomly selects 70% for the first partition, and it randomly selects 30% for the second partition. So that's what we will use. Now you can again look at the help function here to get to educate yourself more on what these different sampling options are. We will use the shuffle sampling option to split the data. Okay, so I could end the tutorial here because I've shown you how to split the data, but again, I think it's interesting to see how one uses the split data, and the specific context that I told you was regression. So I will not spend too much time on explaining the regression model to you. I will just show you how, once you have a regression model, how you use these two splits in the data to actually train the model and then actually to do an evaluation. So let me bring in the regression model itself. So I have linear regression. So here's the linear regression model. Okay, so let me pull this aside a little bit. So the first thing I do is here's the first partition output port. I just connect it to the linear model. So that's how I'm telling RapidMiner the first partition is to be used for training. Okay, and automatically do you see the second partition has shown up over here? And what happens is that now the second partition will be used for actually performance evaluation, and we will bring up this operator called performance. Again, for now, don't worry how the performance operator works, how the regression operator works, because that's not the objective of this tutorial. I'm going through this last bit of discussion just to show you how the split data operation, how it would be used. So I have this performance for regression that I build in. Okay, and in order to feed the data to the performance, what I basically got to do is, after training the linear model, so I trained the linear regression model using one partition, then I would need to take the model and apply it to the validation data. So the second partition, I would need to apply the model that was learned from the training data. I would need to apply that model to the validation data and see how it performs. Okay, and you do that by using the operator apply model. So you can see here, this is the operator called apply model. Let me move this aside. So what apply model does is it has two inputs on the left hand side that you can see. One is it says, tell me the trained model, give me the trained model. So I have connected these two, and then it tells me, give me your validation data. I will apply the trained model to the validation data. So I would connect these two, okay? And then the output of this process would be fed to the performance operator. And then I could, if I move a little over to the right, I could connect the performance operator output to the results and actually see what the answer would be. So again, I don't want to spend further time on this right hand side building the model and actually measuring its performance, because that's not the objective of this video. But hopefully you saw why, or rather how, a split is used. You saw here how a data set is split, and then on the right hand side you saw how the two splits are used. So one split, the first partition, was used to train the model, the linear regression model. Once it was trained, the second partition, which has the validation data, the second partition is fed to an operator. The trained model is fed to the same operator. It produces predicted values, which are then matched, compared to the actual value, and a performance metric is computed. So again, to recap, in this video, I've shown you how to do a few generic tasks. One is how to rename an attribute in a data set. Second is how to select a subset of attributes in the data set. Then how to identify one of them as the dependent variable, how to handle missing values, and then how to partition a data set. Thank you for listening.